right? OK. So you want to work with Bazel, but you don't do Mono-Repo. Now, if you're using Bazel in a Mono-Repo, it might not seem clear what is the relation. And if you're not using Bazel yet, then it also might not seem clear. But if you are using Bazel in a many-repo setting, you know this opens up a can of worms, which we're trying to solve, and so on and so on. But it's not that easy. In this talk, I'll talk about how we got many repos to work with head dependency and be reproducible. So first, my name is Ittai Zeidman. I'm backend engineering lead at Wix.com. I love unblocking developers. Previously, I was the server infra team leader. I founded the team. Over the past 2 years, I've been building our next generation build system, dreaming it, envisioning it, designing, talking with Googlers, and coding it. I'm a co-maintainer of Rule Scala and a co-maintainer of Bazel integration testing, which is a library that enables you to run basically test Bazel inside of Bazel. So if you have Starlock plugins that you want to run negative tests, go check it out. We don't have any documentation, but we do have code, some Python, some Go, and Java. So take a look. And lastly, I'm the proud spouse and father of 3 amazing daughters. So Wix is an online website building platform. We have 130 million website builders, 600 million monthly visitors, 2,000 employees, around 50% in the R&D. Multi-cloud, multi-data center, of course, part of it is on GCP. Over 800 different microservices and over 300 daily deployments to production. Our CI system. We have thousands of build configurations, and every module is a build. We have services that basically automatically discover when you add a new POM XML or a new package JSON, and then they add it automatically to the build server. And they run it through matrix multiplications to find the shortest path, to add the shortest triggers. We use same version, which is floating. So it's snapshot on Maven and latest on NPM. I have more than 50,000 build runs a day on master and millions of test runs on the master. And, this is not as impressive as the stats we saw this morning. But still, we stress out our system. We have 15 microservices just in the CI using Kafka to facilitate all of that. And still, we brought it to its knees. So we needed to build a new system. And that's what we've been hard at work. These are just some of the things that we needed to solve. And today we'll focus on second party. But essentially, trying to get the next scale is, there are a lot of different fronts that you need to attack. OK, so I talked about a few different terms. I said many-repo, head dependency, and reproducible. And that might sound like Greek to some of you. So don't worry, we'll dive into the terms right now. So Mono-Repo. What's a Mono-Repo? It's putting all of the organization's source code into a single repository, right? Git, SVN, Mercurial. OK. Now, we know that all of the cool kids are doing it, right? Google and Facebook and Twitter and Uber and Yandex. Why not do a Mono-Repo? So first, what's a many-repo? Many-repo is when you put your organization's code in many repositories, right? Sounds simple. So why? So a Mono-Repo is hard to maintain at scale. Like I said, we have around 1,000 people in the R&D. We have many commits per minute in working hours. Now, what do I mean by scale and hard? So Git server does not scale very well with the number of refs and number of packs. But you might say, hey, we heard that Google actually have a service, right, CSR, that uses Git on Borg, and that solves the Git server scale. Indeed, but it doesn't solve the Git client scale issues. So just for example, we took all of our code, and with the refs and packs, of course, and put it in one Git repo locally. And simple operations like git status and git stash took many, many minutes. I don't want to even tell you, but much more than 10 minutes. So nothing currently solves Git client, right? But you might have heard that GVFS and Eden and Twitter have a solution for Git, right? And Mercurial also solves this problem at scale. That's true. But none of these solutions are 100% there. Now, I have to say that I think that in a year to 2 years' time, this will be a solved problem. And the barrier entry to using a mono-repo at scale will be accessible to many more companies. But for now, this isn't really a solved problem. If you want to talk and hear a bit more about the details, then I'd be happy to talk to you offline afterwards. OK, so we said many-repo, mono-repo. What's second party? So second party is code that your organization owns, but you do not operate or maintain. So it can be a shared library. It can be an API, right? This is as opposed to third party, code that your organization does not own and maintain, and opposed to first party, code that you actually maintain. So what's second party head dependency? This is having a shared version which is relatively up to date that everyone in the organization is using, right? It can be just using a global version, but this means that everyone is using the same version of the code. Why would you want to do that? So first, because you want to minimize the number of code paths needed for backward compatibility. If I need to maintain a library that supports clients from 5 versions, 3 versions, and the latest version, I have many more code paths that I need to take into account whenever I do a code change. Additionally, you want to find integration issues earlier. So for example, let's say I'm now a library user, and I'm using version 5, and I'm very, very happy. But then I find that version 10 actually has a critical bug fix. I want to upgrade, but then I find that version 8 introduced an incompatible change. Now, some months after this incompatible change, I'm now stuck. So either the library maintainer has to do like a version 11 with some kind of hack to allow version 8, because this is an organization and we work for the same cause, or I need to somehow swallow the version 8 change even though I did not prepare for it. If we were at head dependency, we've found that out much earlier, right? Once that commit was pushed, the library maintainer would have found out that they broke me, and then we would have the discussion. Additionally, you want to increase the usage of shared code and minimize repetition. Now, you might think, how is that related to head dependency? So first, if I can just use all of the organization's code without worrying about, OK, do I have access to that feature? Do I need to upgrade maybe? This is just accessible to me, then I'm more likely to use it. Additionally, if you think about the use case from before, what people might often do is they might just fork out. They would say, you know what, I'll take the code that I was using, I'll just cherry pick version 10, and at some time, I will do the version 8 upgrade. And then we have repetition. OK, so reproducible. I'm guessing that reproducible is pretty clear to this crowd, but still, let's agree that reproducible means that I can run the build again, and if the inputs have not changed, then the outputs will be the same. Why would you want to do that? So first, it allows us to debug production. We can just build whatever is on production again and be able to stress that and see what's happening there. It allows us to debug a specific CI build. So if you think something is flaky, we can rerun that and see exactly what's happening. And it allows us to stabilize the developer's feedback loop. So for example, if they're actually working on a short-lived branch and they just want to see that their code has changed, they don't want to see other things that are thrashing currently in the organization's code, if they have reproducibility, they can get the feedback for what they're doing. OK, so do head dependency and reproducible go together? So if you're using a mono-repo, we're all good, right? Because the identifier of, let's say, Git is the reproduce key. So you just have the identifier, and you get head dependency because everything is the same code. And you check it out, and you run the build, and everything is OK, assuming that you have correct rule sets and so on, right? OK. So if you use versioning and many-repo and reproducible, we're also good. Because you can take a specific repo, take that commit, and inside of it, everything is versioned. So it's still reproducible, right? The dependencies are just versioned. If you want to say, you know what, let's relax the reproducibility. Let's say many-repo head dependency and unreproducible also works. You just resolve every build, you resolve the latest version, and you get head dependency. But many-repo head dependency plus reproducible don't mix that well. I'll tell you a story that how I came to realize that. So we were building, like I said, built a big system, all kinds of challenges, and we were saying, you know what? No problem. We will just have the commits in the workspace file of the other repositories, and we will update them automatically whenever a commit happens. And we're like, yeah, this will work. And we were doing a design meeting a good few months ago, saying, OK, let's understand the details. Let's see that we have this working. And we start saying, you know what? We're not sure this actually works. Because actually we'll have race conditions. What if two repositories actually now updated, and now they need to go and update the third one with the pointers? What will happen? You also might have infinite loops of, I updated your repo for the pointers. Now this triggers everyone else to also update. So you somehow need to break the loop, right? Not rocket science, but still more and more complexity. But definitely the first part of the race conditions of seeing how we can have every repo. And again, think about many commits streaming in, and we need to update all of the pointer files in all of the repos to get the head dependency. And I remember I was sitting in the meeting, and my colleagues were looking at me, and I felt the wind got knocked out of me. So I was just sitting there. I wasn't clear on how we're going to proceed. I'm saying, like, I've been building this system for more than a year, and maybe it's lost. Yeah, maybe there's nothing to do. And for 2 days, I was walking around trying to think what to do. And I went to my manager. And I told him, we have to talk. And I don't know what to do. Like, let's talk. And he listened. And then he told me, you know what? Can we somehow just relax reproducibility? I know it's Bazel and so on, but can we relax reproducibility and get many-repo plus head dependency? Let's solve that later on. And I was like, you know what? I don't know, but it's worth a shot. So let me try that out. And this was our first step in our journey to get many repos with head dependency and be reproducible at the end. So what did we do? Our initial implementation actually heavily relied on a feature of Bazel that you might know, that when the user calls Bazel, it doesn't actually run Bazel. It runs a script that the script takes a look at the tools, at your workspace tools Bazel. If there's a script there, it will run it. If not, it will run Bazel real. And your script can also call Bazel real. What do we use it for? So we have a wrapper script there. The script gets a list of repos in Wix world. It fetches the head commit with git ls remote, writes git repository instances in BZL, and then that BZL is loaded in the workspace file. And later on, we call Bazel real. Now, the BZL is, of course, in git ignore, because the versions keep on changing. And it's created only if it's not there. So you don't actually have to pay the cost every time. What are the pros? So first, it's simple, right? It's pretty simple. It was fast to get up and running. And it very much resembled workspace.resolved, which I think is now obsolete, right? I think it was changed dramatically. But back at the day, it was the thing to be. Workspace.resolved, it was very, very similar. We talked with Dimitri and said, you know what, this sounds like a good direction. What are the cons? So it introduced Voodoo, OK? What is that pointers file? What does it contain? When does it change? When you switch branches, what are the contents? Oh, you know what? Maybe try to delete the file. Let's see what happens. Now, maybe a colleague tells you, hey, I need a help with my branch. You check it out. Nothing works because the branch is older. You delete the file, your file. You run it. Maybe it works. Then you can't come back to your file, right? You have stale pointers because maybe you ran it now, and then you rebased a few hours later, and nothing works because the pointers have changed on master, but you still have an old file. And auditability, right? This ties into this. You don't know what you're running with on anywhere. Lastly, performance. So we're doing the git ls remote. This is concurrently, but still, it took a fair amount. OK, so we understood that we need to go back to the drawing board. And the key thing is to track branches separately, because we want to enable people to switch branches and to be able to know what's actually going on with what they're working on. So we said, you know what? Let's build a custom microservice. And that will just hold all of the versions, right? So basically, that script will tell it, hey, this is the repo I'm on, this is the branch, and it will get all of the pointers that the branch is using. The microservice will get at least the git commits of master from webhooks, and we'll be good. We'll save it, again, in a local cache, in a git ignore, and we will be able to just run it. OK, so the pros are that we get all info in one call from the server, so we don't need to do a lot of git ls remote. We have less logic in the client code, which means it's much easier to distribute and update this. It enables shallow sense, which is a huge Git optimization. So Git does not allow shallow clone. But there are a few workarounds. One of them is shallow sense. And if you do git ls remote, you don't have the timestamps that you need. If the server is the source of truth, then it can hold that. Local cache allows for offline work, and it avoids round trip for every Bazel build. Additionally, this allows for various tracking strategies. So the server is the source of truth, so it can decide, for example, that we don't want to do head dependency. Maybe we want to do stable. Maybe we want to do stable only for a few only for a few info repositories that we want to make sure that don't impact all of the things. But let's have all like 40 of the 50 repos be head dependency. What are the cons? So the second-party versions are out of sync with VCS, right? It's just in the server. Now, building a system to manage the state of all branches in all repos is not that nice, but more importantly, exposing it to developers with the UI and telling them, hey, you know what, go to that UI to update the pointers and play around with that is not something any developer wants to do. Additionally, it requires online connectivity for many more use cases. You open a new branch, and now the server needs to tell you to create it, and so on and so on. And we really like coding on the airplane at Wix. So we send people just on the airplane just to code. So this is a strong requirement at us. OK, so we said, you know what? Let's think about Git, because maybe that can help us and store all that information. So we said, OK, so how will that look? We'll just have the version files tracked by Git. And if you create a new branch, then we'll create a new file using Git hooks. So let's say you check out, you do git checkout -b, then you check out from a branch, right? That branch has versions. We'll just take that. And this is a local operation. So we create the version file for you, and you can just run. And this is tracked, so you can git commit and git diff, and so on and so on. And we have a git hook, another git hook, a different one, that manages the symlink. So basically, remember the workspace file, it still loads one BZL file. And we have the git hook that changes the symlink according to the current branch. OK, and that's also in git ignore. Now, you might ask, OK, but how do you populate it once? So we have a microservice for other reasons also that has a list of repos. And we do get git ls remote. This is to build the first time ever master version. Additionally, this is something that is used by a CLI tool for developers, right? Because if they want to reset the versions. OK, so what's good about that? So mainly it's solving the problems of the custom microservice. So the second-party versions are in sync with VCS. They are in VCS. Managing the state is easy. It's in Git, right? We all know Git to diff it, to commit, and to see exactly what's happening and every change. And Git is decentralized, so many of the use cases are now can be local. And it allowed us to have history of second-party versions per branch per commit. OK, but what are the cons? So only one, but a huge one. The second-party versions can be very, very volatile, especially on master. So now, if you want developers to manually maintain the master file, then you first have version drift, because I don't really want to maintain it. So we'll usually do head dependency. And more importantly, I will have merge conflicts. Because let's say George and I go from the same commit. Now, we both change the same file, the same master versions. Now, when I go to commit after him, I have a merge conflict. So that's not really a viable option. But then you can say, you know what, let's automatically maintain it. But then we go back to the same original problem of race conditions and infinite loop breaking. So at this point, we realized that treating master and other branches the same is just wrong. And we need to somehow mix both solutions. So how does this look? OK, so we still have a microservice, and it stores the latest version of master in all repositories. So again, Git gets webhooks from Git. It knows this is the master version. The script calls the microservice to get the master versions of second party. And those are not tracked by Git. So those are resolved every time you work on master. A good use case for working on master is CI. So basically, on CI, we resolve the versions each time from the microservice. We just get a response with the Starlark file. Yes, I wasn't sure I was going to say Starlark. Definitely a mouthful. OK, so that's automatically resolved, and the content is in git ignore. And the non-master branches are tracked in Git. Now, they are manually curated, and we just added hooks to, we still have hooks, but they are different. Their purpose is to help you as a developer ease the manual creation. So for example, let's say you rebase. You pull origin, and now you want to rebase. If you're rebasing, you're taking the code, right? You're taking the code from origin. The code probably depends on other code also on master. So if you rebase, we also want to rebase your pointers. So we have hooks to correlate between the code and the pointers. Now, we carved that out so that this is still semantics very similar to Git. So when Git is online, we will be online. When Git is local, we will be local. And the developer will not really notice. And we still have the Git hook that you know from before. OK, so what are the pros of this? So we don't get merge conflicts. We don't get version drift. And we don't get race conditions. Really big pains. Additionally, we get all info in one call. So just on a small scale, right, like 5 repositories that we played around with, given now it's on a developer machine and not on CI, so networking does change, but we got it down from 10 seconds to 1 second. So 10 seconds with the LS remote, 1 second with the server. Sorry, still enables shallow sends, because the thing that promotes all of this is the server. And we still don't need to pay the round trip. Lastly, the second-party versions and VCS are mostly synced, so not for master, but for all other branches. Still allows for offline work, and still supports tracking strategies. What are the cons? So we need to clean up old second-party versions, right? Because we just keep on committing those files. OK, but that's actually a problem also with Git branches. So it just so happens that we have a service that actually prunes out old branches that aren't really needed. And we just make that service also clean up those files. OK, the client is not that thin, right? Price of doing business, right? That's just the cost of doing business. We will find ways to distribute that, which will be relatively cheap. Auditing master. So you'll say, you know what, but you're not tracking master. What do people do? So what we do is we just output in the build. We output the file, and we store that as part of the build output. So for our use case, this is part of, this is just a target in Bazel. And then the developer, if they want to reproduce a build of master, they can go, they download that file, and they run it. And that's it. They just get reproducibility also on master. So it's not tracked by Git, and it's like 2 clicks away, but they have it. Lastly, some people might need to understand this master versus non-master logic. But I think that the main takeaway is that these cons are operational and small scale. They are not functional. Like previously, all of our iterations were, you know what, this will not work. You know what, this will usually work, and sometimes people will be really, really mad and saying, hey, get your stuff together. So all in all, net, we're really happy to get it down to operational issues. Yeah, some more thoughts. This is like the advanced. I'm not sure I'll touch on everything because I think it's a bit too much. But so first of all, what's the version? Because you have many repos, so there is not really a version, right? There is not. If you have a mono-repo, you have a version. So for us, the version is the aggregate of all commits. So this version list is the version that you want to speak about, because this represents the code that was used. What should the server respond? Should it respond with JSON, Starlark, both? So we started JSON, but then we said, you know what? This means that the client is, again, like a lot wiser, because it needs to format the Git repository. If we want to change to HTTP archive, which we're actually considering, then the client needs to be changed. So we said, you know what? We just return both. The Starlark file is taken by the script and is used by Bazel. And we use the JSON for other stuff on our CI that propagate it. And basically, this, again, is the lock. This is not the lock, but this is the identifier of the code, the JSON response. Ordering. How do you do ordering in many-repo head dependency? Like, what's first? So we said, you know what? Let's just take the committer time. But then we said, committer time of what? Of the repo? But maybe you were triggered by another repo, right? Because they merged to master, and now you were triggered. Your time did not change. OK, so we just took the maxed committer time of all repos, because that's the latest one. But then we found out that actually, committer time is not that good. Because when you do a rebase, committer time changes. When you do a merge, committer time changes. When you do git cherry pick, committer time does not change. So thankfully, we use GitHub. GitHub has a pushed at timestamp. So we just use the pushed at. And this max pushed at timestamp is what we use for ordering. I hope their clock will not get out of sync, or we will have problems. But yeah. I think one last thing is basically why we chose to encode all of Wix repositories in the same in that file, because maybe not everything needs everything, right? So we actually in our current system, we don't do that, and we built a separate system that tries to understand the dependencies between modules. Here it's repositories, and we did not want to go into that avenue of saying what repo needs what repo, because the whole external repository story, workspace.resolved, and recursive workspaces is very much, I think it's not in the dark now, but it was like 6 months ago, 7 months ago, it was much more in the dark. And we said, you know what? We don't want to build a system that might not be relevant. So we will just use that, and we will optimize along the way. Because basically, this is just cloning, and it will only happen if you actually need it. Thank you.